Sweet. Alrighty. So for anybody who is watching the video of this, this is the second Mechatronics meeting on September 30th, and this is SolidWorks 1. Real quick before we start the actual SolidWorks training itself, I'd like to go over a couple housekeeping things. Most of you who done these things, I think, but I just want to make sure that everybody is all caught up on this. So there's kind of three main things that I want to make sure you guys have going into today. SolidWorks, the Google form, and Discord. I'm going to drop these links because you guys can't copy them from here, and copy, like just typing these out would be super annoying. So I'm going to put these in the chat. So this first one is for SolidWorks install if you are a COE student. The second one is a SolidWorks install link if you are a non-COE student. I will add that there has been some problems with this, I've heard. So if you fall into the non-COE camp and are having issues with this, sit tight, and I am going to put in the chat that you're having trouble with that, and I will try to get a solution for you. The next one was the Google form. If you already filled, that's the same Google form from last week. So if you've already filled that out, then you're good. And that's just so we can make groups. And then the last one is for Discord. That's just the same Arrow and You Discord. So if you're already in that, that's great. But if you are not, that is our main form of communication, that we will be transitioning that more and more and away from email. So if you guys can get into there, that would be awesome. I'm going to give you guys like a couple minutes to do this stuff. It's really important that this stuff is all set. And this is also a good time if people are having issues with SolidWorks to mention that either in the chat, you can unmute yourself, whatever. I'm just going to give people until like 8:22 or whatever. All right, cool. I think we are going to get going on the rest of the SolidWorks training tonight. But please, please, please make sure before the end of the meeting tonight that you guys have at least Discord and the Google form filled out. If you're still fighting SolidWorks, just let me know that, and we can continue to work on that throughout the next week. But I really need that Google form and Discord because that's how I'm going to be reaching you guys, and I'll be making the groups before next meeting. So I need to have that information. All right. Cool. And with that, I'm going to pass it off to Bryce, and we will begin working on the SolidWorks training.
Cool. Full screen. All right. So judging from your Google form responses, those of you that already filled this out, a lot of you are very interested in learning SolidWorks from us, which is great because we're happy to teach you. We use SolidWorks for pretty much all of our aerospace projects. We use it for CAD, but really it's awesome for the whole design process. So even if you don't know exactly what you want, you can start modeling right in SolidWorks and get a pretty good idea of what you're going for before you've even made anything, which is really powerful. So SolidWorks is an industry standard CAD tool. CAD is computer-aided design. So it does really well in academic and small business sectors. Despite all of the troubles that we're having with downloading it, their model is pretty much get it in the hands of students as early as possible, so you become hooked on their shiny user interface and want to use them forever. So we're going to be going about teaching you how to use it. And then also, in addition to learning the buttons and where everything is, which is an important part of using the tool, we want to teach you good practices. So while you can look up where different bells and whistles are in the software yourself semi-easily on the internet, it's not always easy to learn how to go about modeling parts and assemblies in a good way that's going to keep them robust and adaptive. So we're going to be trying to teach you the best way to actually go about making parts so that you don't have to do so much work if your design needs to change. And we'll go through what all I mean by all of that. But basically, we're trying to make it an efficient process for you. All right, so jumping right into it, what are the steps of our modeling process? So to make any 3D part, we start with 2D sketches, and then we're going to use features to make them three-dimensional. So in the case here, I've got a circle that's got some dimensions and constraints on it, and then I can either take that and make a cylinder, or in this case, a donut. You could do different stuff with that, but we're basically taking these 2D images and moving them into 3D. The other thing to know about SolidWorks that's nice, and a lot of industry standard parametric CAD softwares are doing this, it's a dimension-driven software. So what that means is, I don't know if you can actually see my camera or not. I talk with my hands a lot, so that's probably helpful if you can.
We can, yep.
Okay, cool. Well, if I was gonna, model this tape dispenser, what that means about being dimension driven is that I don't actually have to know like all of the coordinates of the points of my tape dispenser ahead of time. So some of the most original CAD softwares, such as AutoCAD and stuff like that, might need you to know where all these points are. Like, let's say my origin is here and this is going to be a little bit left and right or whatever. You'd have to know what those points are beforehand. Something that's really nice about SolidWorks and a lot of these other softwares is that you can first draw in your shape and then constrain it later using relations, construction geometry, and dimensions. So we're going to be talking about how to do sketches and use these three things to define them fully and keep them robust. So I've got a note down the bottom here that says that these are in a particular order. And what that means is we want you to apply them in this order when you're going through sketches. So you start with relations, move to construction geometry, and then you use dimensions last. We'll talk about why this is so important, but the basic idea is if you're using just numbers to define your parts, those won't necessarily update themselves. So like, let's say that I want a feature to be right in the middle of a block that I've already started. If I do the math and I figure out, okay, my part is 2 inches wide, I want it to be 1 inch from one side, then if I go to change that later, and let's say my original width is 3 inches, now that's not necessarily in the middle, but if I define it to be in the middle of the part, then that can be a lot more helpful. So we'll go through what all of that means. All right, so to begin a sketch, we're going to start right up at the top in the top left corner and begin a sketch. And then SolidWorks will prompt us to pick some sort of flat surface. So that can either be the three planes that we start with when we create a part, top, right, and front, or it can be existing flat surfaces and geometry that you've already started, or it could be reference geometry. We'll talk about what reference geometry is, but it's basically extra planes or axes or whatever that you want to add to your part. Maybe you have to define something, some special feature. So once we've started the sketch, we can start adding in our sketch entities. These are different shapes that you can add. They're all 2D, so you can do, your basic stuff like lines, circles, rectangles, arcs, polygons. You add those in, and then you're going to be able to constrain it using relations and the other things. So in this case, we have our rectangle. Y'all can see my mouse, right?
Yeah.
Take that as
we
yes.
can see your mouse.
Okay, so you got this rectangle that's in there on the origin as the start of the sketch. There are also some tricky sketch entities that we want you to avoid, at least starting out, because they can be pretty tricky. In particular, sketch fillets, mirrors, and patterns are generally not as robust. Usually when your design needs to change, they're the first things to break in a sketch because their references become outdated or whatever. Luckily with these ones, there are plenty of feature-based alternatives to use instead, so we'll show you where those are. But just know when you're starting out, those can be kind of tricky, so I would recommend staying away from them. All right, so our three pillars were relations, construction geometry, and dimensions. So relations are the first one of those. So once I've got my sketch started with whatever shapes I want to incorporate, I'm going to need to add relations to that. So like, let's say I have a line. I want that to be horizontal or vertical relative to whatever planes I've started on. In the case of my rectangle, I have these lines. SolidWorks will also try to guess some of these as you're drawing. Sometimes that's helpful. Sometimes it adds ones that you don't want, so just be aware of that. But these little green boxes here are those little symbols for the different relations that it's added. So this is the horizontal line, this is vertical, these ones are coincident. And as you get to model, you'll understand what these are when you see them, and they make pretty intuitive sense. There are a bunch of these, parallel and perpendicular, equal. Let's say if I wanted my rectangle to be kind of cocked to one angle, instead of being horizontal and vertical, I want it to be off at some angle for my design. I can set, you know, that these should be still parallel and these would be perpendicular to each other. But I wouldn't necessarily have to rely on horizontal and vertical, that sort of thing. A lot of these are pretty intuitive. You get into some fancy ones here. As you get to practice, those will come to you. But tangent is another one we use a lot. If you've got any kind of curve that needs to meet a line, that's pretty helpful. Just touches at one point. So a lot of geometry in CAD. That's 3D spatial reasoning. It's all over the place if you're doing any kind of design work. So yeah. Construction geometry. So this is geometry that's used to define your sketches without being part of your features. So what do I mean by that? Let's say that I'm looking at these features here in the picture, where I've got these circles that are going to be going on my existing block. I want to define where those blocks are, or where those circles are going on the block, but I don't necessarily want to use dimensions because those are a dumb number that I've typed in that won't update itself later on. So these diagonal lines are kind of a fancy geometry thing that you don't necessarily need to do. You could do this in a couple different ways. There are a million ways to skin a cat, but you could define where these go using construction geometry, and then later on your sketch would update by itself if the dimensions of this block were to change. Something to note about this is your dotted lines will be construction, and your solid lines will be non-construction or feature forming. So these solid blue lines are going to be the ones that end up being the holes in this part, whereas the dotted lines aren't. In SolidWorks, you can use the center line tool that'll make construction lines from the start. For the other sketch entities, you need to create them as solid lines and then later manually change them to construction geometry. But they're definitely very helpful to use this because it saves you a lot of work on the back end. All right, so I've been harping on this quite a bit, but just to go over it, dimensioning is the final one we want you to do because that'll save you the most work. So that's just how big something is. How long is it? How great is the angle that you're trying to create? Or how big is a diameter or radius of a circle or arc you're trying to make? So in this case, the picture I have here, I only need this one dimension to fully define my sketch, which is really helpful if I don't want to have to manually define each of these circles separately and where they are and all that. Another thing to note about the difference between this sketch here and the one above it is that my circles changed from being blue to black. So this is really important because it's able to fully define my sketch. When it's blue, when you start modeling, you'll actually get to see this, but you could drag this circle around to make it different sizes and shapes. Not shapes, it's a circle, but you could make it different sizes of circle, basically, wherever it has degrees of freedom. But if you have a solid sketch, everything is fully defined. It won't move around. It's exactly the size it's going to be, and your features all the way there. If you don't have that, the computer will just put in whatever dimensions it does. So your design isn't necessarily what you actually intend it to be. And also it can do some wonky things. If you have features that aren't fully defined, sometimes you'll grab your part and it'll accidentally like extrude something more than you want. You really want to always define your sketches fully so that you don't run into any issues with that. We don't like blue lines here. One other tool that's pretty helpful when you're making especially more complicated sketches is called Power Trim. So there's the trim tool, and then Power Trim is just kind of a fancy version of that. But basically, if you have a bunch of contours in your sketch, You could go through and delete the overlapping lines to just get that one contour that you actually care about. So in this case, you could have that closed-in feature. The closed contour is this shaded shape that I'm talking about here. So SolidWorks will let you know when it's like ready to make a feature that you've defined. So you could then take this and extrude it or revolve it or whatever you want to do feature-wise. All right, now, so we've defined what our 2D sketches are going to be, but now in order to make 3D features, 3D parts, we want to use features. So there are a few different ones that we're going to talk about here. There are a ton of features that we're not going to talk about, but they're very helpful as well, but a little bit more niche. So we're going to try to go over the most important ones that you'll be using all the time. And then as your applications need it, we might help you in a different context to figure those out. But these are the ones you're going to really use a lot. All right, so the first one that's your workhorse feature that you'll use all the time. It's really hard to think of a part that you wouldn't use this for in some way. Is Extrude Boss Base. So this is just taking whatever 2D geometry you have and adding one extra dimension to it. So in the case of the cube, I have this square that I've defined. This could be a rectangle or whatever. And then I'm just adding one more dimension to it. So I'm giving it height or depth or whatever you want to call it. Circle becomes a cylinder, that sort of thing. It's just a straight addition of material to whatever 2D profile you have. Extrude cut is pretty much the same idea. If I had this cube and I add another square in the middle, I could ask SolidWorks to, instead of adding material, maybe take it away the other direction. So now I have kind of my square donut. All right, so when we're talking about these types of features, we want to think about our end conditions. So we've told SolidWorks, okay, I have this 2D profile and I want you to do something with it, but we haven't told it what it should stop at. So what I mean by that is I have this cube and I've given it a 2D profile, but I haven't told it how far I want it to actually extrude it. So what I want to do on an end condition blind is tell it how far I'm actually doing that. So in a lot of these images, they're all related. So you'll be able to see kind of what the differences are, but in this, the red line is telling you how far from this orange starting plane we're going. So it's just a dumb dimension, like I've been talking about, which is useful sometimes, but again, a little bit less robust than some other end conditions if that's not what you need all the time. But it's basically just telling you how far to come off from the original flat surface. All right, another one, I see it very rarely used for extrude boss bases, but a lot more for cuts is the through all end condition. So this would basically take whatever the extent of your geometry that you have, whatever part you have, take that profile and move it all the way through the material you have. So like, let's say I wanted a hole.
I'm pretty sure you can't extrude boss base through all.
Okay, that would make sense. If you did take a hole and put it all the way through, that would be the main use case for this end condition. But yeah, not always what you want, sometimes useful, but when we get to workflow and what rollback features are, we'll see why that might not always be the best case. All right, now midplane. So this is very similar to the blind, where it takes one direction and it just adds material. But in the midplane, you take the original brown plane that you're starting on and you add material on both sides of that. So you'll have this plane that you start on right in the middle. I use this feature quite a lot. I know Scott loves it too. One of the main use cases that we really like this for is when you first start out on a part, you'll get 3 orthogonal planes. So you have right, top, and front. And you'll usually begin a sketch, and let's say you put your geometry right in the middle of those 2 planes that you're sketching on. When you do make this a 3-dimensional feature, and usually your first feature is like the big meat of your part, if you're thinking about it. If you do a midplane end condition, what this will do is put one of those planes right in the middle of that part. So later on, if you want to do, a pattern or a mirror or something like that, you'll be able to actually pick up that plane already there instead of having to define your own reference geometry later on. We'll talk about reference geometry, but yeah, pretty useful to at least start out, and other conditions is pretty nice. Up to surface. This is another one of the ones that's really good. So this will take your sketch from the brown plane and move it right up into a surface that you specify. So in the case of this, you take whatever contour you're doing and you specify, okay, go up to this surface here, and we'll stop right there, whatever it is. So this can be sometimes more useful than, let's say, a through all, because if I know that I want to go through all up to this surface, then it'll do that. If I'm doing rollback stuff, then sometimes that can not do what you want, and we'll talk about that. Okay, so our next kind of feature is a Revolve boss base or Revolve cut. So it's similar to extrudes, but now you're adding axial symmetry. In this case, I've got kind of my L-shaped sketch, and then I'm gonna revolve it around this entity here. So it becomes its center line. It's able to have that axial symmetry. So now I have this cup shape. You can also do this, like, let's say you're gonna make, a cut. You can also do that. It's just pretty much the same idea. Another thing that we use all the time is patterning and mirroring. So this saves time by repeating features that already exist in your part. So let's say I've got this disc and I've got a hole through it. If I want to repeat this hole around, I don't have to separately do 4 extrudes or do 4 extrudes in my one sketch. I can make this one feature and then tell SolidWorks, well, I would like to repeat this 4 times around, or let's say that this wasn't a circular part. I could also mirror it using a plane that's in the center of the 2 features that I want to create, and it'll still save you a lot of time. All right, now I think I've mentioned a few times now, but reference geometry is really helpful for defining features that you might want that you wouldn't necessarily be able to get otherwise. So let's say that I want to make this part, and then I'm going to add a feature over here, and I want to mirror that over here. If I were going to do that normally, I wouldn't really have anything to mirror it across because my default planes are not in that axis. I can't mirror it across planes I don't have. So if I want to create something that I can do that with, I need to define it myself. So if I'm going to define a plane, I just say, okay, it's a certain angle offset of one of these, or it's through this axis, or whatever. You can play different games with it, but it's really helpful for defining some fancy features that might come at different angles and stuff like that. All right, now we also use fillets and chamfers all the time. These are really helpful finishing tools. They just add, chamfers are the angular one. They just add a little knock off the corner. And then fillets are the curvy one. I don't know how well you can see it in this picture, but this is some radius that you have going between 2 features. This is really useful. Breaks sharp edges, you won't hurt yourself, reduces stress concentrations. If you're meching, you might take classes later on that will tell you what that means, but basically if you just have some extra meat here instead of a sharp corner, that will reduce how much load is taken right at that corner, and you might have less breakage in your part. And then it can also do helpful things like lead-ins for holes. Let's say I wanted dowel pins to go through these. I just want some metal rods to go through those holes. Sometimes if you have a sharp corner, it can be kind of hard to get your dowel pin right in there. It's just kind of difficult to work in. But if there's a little lead in there, it can make that a lot easier. It's like a funnel when you're pouring gasoline. Just very helpful. These are very useful features. Definitely recommend using them. But generally, you want to do this at the end of your part just to save yourself some grief. Usually these are like kind of finicky features. So if you have them in the middle and then stuff changes earlier on, it can break. So just be careful with that. I'm sure at some point you'll have to deal with fixing it, and you'll get why I'm saying this, but just be aware. All right, now, another thing that's super awesome about SolidWorks is they have the whole wizard. So this is a really helpful tool if you're using any kind of standard hardware. So we're definitely going to advocate for using screws and everything like that in your designs. And this really makes it a lot easier to incorporate that than if you had just regular extrude cuts or whatever to put your screws through. So you can just go through. It's a pretty intuitive menu on the side here, but you have a few different types of screw holes that you want to do. So you could just do a through hole. You could countersink it if you had like a flathead screw that's got a cone on the top. You could counterbore it if you want to sink a head in. There's all sorts of different features that you can do here, but you pick out, you know, whatever standard of hardware you want to use. You say, okay, I'd like to have a screw clearance. I want the screw to go all the way through. You could do a tap drill if you want to specify on a drawing or something like that, that somebody's going to add threads to that hole so that a screw can pick it up. That's also really useful. And then you just say what size of screw, what the end conditions are. Those are the same end conditions that we've already talked about. And then, you know, it'll walk you through it mostly. And then you can select your positions. And it's really helpful if you want any kind of hardware to integrate with your design, which will definitely happen. Okay, so this is the rollback and workflow slide that I was talking about. So SolidWorks has this thing on the side as you're modeling called the feature tree. The feature tree, I think, in SolidWorks. In Korea, it's the model tree. So yeah, I'm gonna go with feature tree.
It's the feature tree, yes.
Okay. So anyway, you've got this thing on the side that's really useful for manipulating any kind of feature that you want to edit later on. So as you add new features to this side here, you'll be able to manage them by right-clicking and editing or editing your sketch or whatever you want to do. There's also this thing that's the rollback bar, which you can manipulate to show different stages of your part modeling. So like, let's say that I've modeled these 3 features and I would like to add in a feature before Boss Extrude 1 in this case. I would roll this back. I can now add new stuff, and then I can put this bar back down and it will add those features back in. If the references work, that's really nice. Sometimes that will also break things, but you still want it to go there, so you still need to fix some stuff, but that's definitely pretty useful. So let's go back to the case that I said at the beginning when we were talking about through all. This is kind of more advanced, so if this kind of goes over your head, it's all right. This is like definitely something you'll encounter, so you'll learn it, but this might make sense if you've used SolidWorks a little bit or just any kind of CAD. Let's say I start with this base extrude. I've got my cube or whatever, and then I'm gonna cut through my whole cube. I've got like a hole down the center. Then later on, I add in a couple extra features, and then I decide to roll back and add something in. What might happen when I move this back down to the present, I guess you'd call it, like where you're actually at the bottom of the tree, is that through all might end up cutting through my features in a way that I didn't anticipate or something like that. So that's what I meant when I was talking about rollback and workflow. But we'll definitely cover it if it ever comes up. I mean, that's why we have mentors here, is to help you with weird effects that you don't anticipate happening. But yeah, just something to be aware of. Yeah, and then the other thing about rollback and workflow is that sometimes when you reference things, let's say in this, using construction geometry that's based on my corners or my edges. If for some reason I went back and cut out this chunk here and then tried to roll back to this, SolidWorks doesn't know where this point is anymore because it doesn't exist in space. So it would get kind of confused, and you might have to redefine how things are defined if you roll back. So that's something that definitely will come easier as we get more comfortable with all this, but it's worth mentioning, definitely. All right, so let's say that you've made all your parts together and you want to figure out how they're going to actually assemble. So this is actually, I'll grab it real quick. So this is actually the Geneva drive mechanism that we're going to be working on in class 2 and 3, possibly, where, I don't know, can you guys see it? If I'm trying to get in front of my background, I hope. But yeah, so if you have parts that you've modeled, you can now specify how you want those parts to actually interact with each other. So this is really useful for us when we're designing payloads and we have different parts and we want to see how they fit. Most of the time, when you're actually assembling something in SolidWorks, it will teach you a lot about things that you couldn't really picture in your head, how things are going to fit together, and you kind of catch a lot more stuff that way than you would before you actually have to print it out and see how it fits. So that's very useful as a tool. One of the main advantages of doing all of your CAD very thoroughly upfront is that you save yourself work in real life before it actually has to happen. All right, so different types of mates, just like we have different types of relations in our sketches. So these all just kind of do different things with controls for the 3D parts. If you're coincident, those are two faces touching each other, parallel faces, that sort of thing. And then you'll get the hang of this as we move through the exercises. But each one of these has a different use case, and they're all based on just the 3D geometry that you create. All right, I'm gonna let Scott talk about GrabCAD.
Great. Thank you, Bryce. And for those of you who didn't see, I'm still working through putting you guys all into the spreadsheet, but I asked if you guys have successfully installed SolidWorks 2020 to please put that in the chat and say yes. And if you're still working on that, say no. And if you don't have 2020, but you have a different version, say no, and then say which version you have. Just want to know who has CAD. Looks like a lot of you have it or have a different version, which is awesome. So for those of you who don't know, GrabCAD is a software that we can use to share CAD between different people. So the way that it works is you have a project in GrabCAD that will have a local folder associated with it on your computer. And then the GrabCAD Workbench application can track differences between your local folder of this project and other people's local folders of this project. And you can push or commit CAD to the cloud, which allows other people to pull that content down to their local folder, or vice versa. You can pull down other people's changes. Of course, like all collaborative applications, be it GitHub with code or GrabCAD with CAD, or I'm sure there's a bunch of others that I'm not thinking of right now. You have to watch for like essentially merge conflicts, where if both people edit the same file and commit it to the cloud, then the cloud's not going to know which one to use. So we'll have to be careful with that. But at least for the beginning, I don't anticipate any problems with that. So what I'm going to have you guys do is make an account with GrabCAD. If you haven't already, if there are anyone who has been in the club before, you almost certainly have done this before. Here, I'm going to grab the... Bryce, can you throw the link to that in the chat for me? Should be yeah. Yeah, so when you go there, you can make an account. Please do so with either your Northeastern or either your at northeastern.edu account or at husky.edu account. Either way, we try to keep Aero and GrabCADs within Northeastern if possible. Once you've done that and you log into your new account, you can go to, there's like a Workbench dashboard button. And you can see in this picture here, that screenshot, there's a download app. I have an arrow pointing to it in the top right. Once you do that, you'll go through a standard Windows install of the GrabCAD Workbench application. At that point, shoot me or any of the mentors. Actually, just put it in the chat to everyone, so one of the mentors can grab it, because we can all add you guys. which email you use to make your account. I imagine for most of you, that's going to be your Northeastern account. But especially for those of you who have been in the club before, it might be your Husky email. So I just want to make sure that doesn't get confused. And we will add you to the project. Once you have been added, you should be able to link the Mechatronics project to a local folder. Doesn't matter where it is, just put it somewhere that makes sense to you. And yeah, I'll get to the other stuff after we get a little further along. I know I just threw a bunch of instructions at you guys. For anyone who's used GrabCAD before, this should go pretty quick. For those of you who have not used GrabCAD before, it might be a little bit tricky. So please ask questions if you have any. And unlike the SolidWorks download, this one doesn't take forever. So this should theoretically be easier. All right. I'm going to give you guys a couple minutes to do this. Yeah.
All right, so I'm going to add into the chat now the link to this presentation so that everybody can look at the last few slides we have. But basically, what we have for the rest of tonight is some practice activities. So now you've heard me speak and might not know what I'm talking about. We want you to actually go try it out. So we have some practice activities prepared where you can go through and just try out some basic things. You could do whatever you want in SolidWorks if you've already got some experience with it. But basically we just want to have you try out some basic shapes and stuff like that with all the mentors here, which, you know, if the need arises, we might break out into breakout rooms so that we can split it up a little bit if you guys have more questions. But basically just a couple of little exercises that we can do just to get our feet wet.